Hello everyone, my name is Ketan Rajesh Shande and today I am going to present on the topic ReLU, Revolutionizing Deep Learning. These activation functions played a key role in making modern deep learning possible. What are activation functions? In a neural network, activation functions are like decision makers. They decide whether a neuron should activate or stay silent. Without them, a neural network would just behave like a simple linear equation and it would fail to capture real world complexity. For example, if we are trying to identify whether an image is a cat or a dog, activation functions help the model learn nonlinear patterns like recognizing curves, edges, and textures. Old activation functions. Earlier, researchers used functions like sigmoid and tan. The sigmoid function squashes values between 0 and 1, while tan squashes them between -1 and 1. These functions worked for shallow networks, but in deeper networks, they had a serious issue known as the vanishing gradient problem. This means that during training, the updates to weights became extremely small and the network almost stopped learning. This made it very difficult to train deep neural networks. What is ReLU? Then came ReLU, or Rectified Linear Unit. It is incredibly simple but very powerful. The function is defined as f of x equals the maximum of 0 and x. In other words, if the input is negative, the output is 0, and if the input is positive, the output is the same as the input. This small change solved many of the issues faced with older functions. Why ReLU is better? So why is ReLU better? First, it is very simple to compute, which means training is faster. Second, it avoids the vanishing gradient problem for positive values, so deep networks can actually learn effectively. Third, it introduced sparsity in the network, since many neurons output 0. This sparsity makes the model more efficient and easier to train. Because of these advantages, ReLU became the default choice in almost all deep learning architectures. Limitations of ReLU. Of course, ReLU is not perfect. One major problem is called the dying ReLU problem. If the input to a neuron becomes negative, the output is stuck at 0, and that neuron may never recover. This makes the neuron effectively dead. To solve this, researchers proposed variations like leaky ReLU, which allows a small negative slope, and parametric ReLU, where the slope is adjustable. These improvements help reduce the dying ReLU issue. Applications of ReLU. ReLU quickly became one of the most widely used activation functions. It is used in convolutional neural networks for tasks like image classification, where it helps recognize objects like cars, animals, and faces. It is also used in natural language processing, where deep networks can understand and generate human language. Speech recognition systems like Siri and Alexa also benefit from ReLU-based networks. Even in cutting-edge architectures like transformers and large language models, ReLU and its variations play an important role. Summary. To summarize, activation functions allow networks to learn complex patterns. Older functions like sigmoid and tan were useful but limited by vanishing gradients. ReLU, with its simple yet powerful formula, solved many of these problems, making deep learning practical and efficient. Although it has some limitations, improved versions like Leaky ReLU have extended its usefulness. Today, ReLU is considered one of the most important breakthroughs in the history of deep learning. Thank you. Thank you for listening to my presentation. I hope this session gave you a clear understanding of why ReLU truly revolutionized deep learning